Hello and welcome back to Undet for Revit. In this video we'll learn how to create detail images using Undet for Revit. So to start with, we have to go to Undet ribbon, click on Add Slice. It will open us a slice manager. Then set project as usual. Always use the last used and modified Undet coordinates because what we changed we want to keep it as it is. Then for example, now in level 1 we cannot see anything for now. We'll just use preview so that we know the location of our building. Okay, so we know it locates somewhere here. So now we have three options, three kind of raster images which we can make. So it's floor forward view, then center view and ceiling view. So for floor forward view, what it does is if we check the view range. So for floor forward view, it takes the cut plane defined in the view and from the cut plane till the bottom of the view and use all the points which we have collected in this area and use this to create a raster image. Then for center view, it takes only the cut plane line and offset it on the both sides and make a 70 millimeter thickness offset and use that information to create a raster image. Then for ceiling view, it takes again the cut plane till the top of that view and use that information to create a raster image. So depending on the functionality, depending on the work which we are going to do, depending on the information we need, we can switch between floor forward, center and ceiling view. So let's start, let's try to work with them. And also all these settings again depends on the view range. It always take the cut plane from the default settings of the view range. It uses top and bottom for the thickness, and we can also change it manually if we need, but I would stick at starting at least with the default settings. We can offset this cut plane and all other information also with just writing here. For example, if I need it 5 meters above the default cut plane, and that's it. So let's try to create an image and see how it works. So if I want to create a floor forward view, which is from the center, from the cut plane till the bottom, we click on floor forward view, then choose our resolution, and let's try define view for this instance. And if we define this area, it will create a raster image only for this area. It can take 10 minutes, 1 hour, sometimes half a second. It depends on how many points there are in the point cloud file and what are your specs of the computer and how big, what's the dimension of the raster image we chose. And there we go. So now, for example, in full forward view, we can see the furniture, couches, tables, and all this information with the walls, and also the openings for the doors and windows and other things. So we use defined area. Let's try to use the same settings, but for screen area. So screen area is just the part of the view which we can see on our screen. It will create raster image for that. So again, floor forward, choose your resolution. So it's floor forward, choose your resolution and screen area. And there we go. As you can see, it chose the whole area in the screen and created a raster image. But I would recommend sticking with only defined area because sometimes it can take a really long time, as we just saw. And we can also update the image which we already created by just choosing the image. And let's say right now it's at 5 millimeter resolution and I wanted, let's say, a 1 millimeter resolution. So I can just select and choose resolution, and if it doesn't change by clicking, we can just click on update selected, and that's all. And there we go. As you saw, the better the resolution, the longer it will take, but it will have more crispy lines which we can use to model more accurately. So the idea is to create these images only once, not multiple times. So we should be careful before choosing the best resolution to make an image and test it, and then choose the best resolution for the same image. So far we have already created floor forward view. Now let's try to create center view. So let's try to click center view, choose your resolution, and again defined area. So center view is, as I said before, it's a thin slice of point cloud around the cut plane, and use that information to create a raster image, and that's all. So now right now we cannot see. Let's try to hide the preview image, and here we go. So as we can see, it's a thin slice, so it has only small amount of information, but it also remove the overlapping of different kind of information at different elevations and things like that. And in the center view is mostly useful for walls, creating walls and other things at a better accuracy, because it's more sharper and clearer information. Then for ceiling view, let's check section first. So somewhere around here we have a ceiling. So let's try to click ceiling view, choose a resolution, and defined area. And there we go. Now we have a ceiling view. So we have learned how to use floor forward view, ceiling view, and ceiling view. There is one more interesting thing which we can do with center view, is merging center view with other information. So let's say we had a floor forward view like this, and we can turn on the center view layer, and now it combines, because center view layer, wherever there is no information, is white, it's transparent, so whatever is behind that we can see it. So when we turn on any image behind it, it combines and give us a better maybe information and easier to understand. And that's all for floor views and how to create detail images and floor plan views. Next we'll go with sections. So far we learned how to create detail images in floor plan view. Now next is section. So let's try to create a section first. So for section view also, it's nearly same as creating raster image in the floor plan. So we again have floor forward view, center view, and we don't have ceiling view, but we can choose backward view, which is kind of like ceiling view in section. So we'll talk about them one by one and how it relates. So floor forward view, you see the thickness is around 1.3 meters. So this thickness comes from the settings which we created for the section, which is far clip offset here. So the further we set the offset, it's the same for the thickness. It changes according to the offset we set for the section. So for now it's 1.198. So if we click on floor forward view, it will go to, the thickness will become 1.198. So let's try to create a preview first, so that we know where our building lies. And same as before, floor forward view is from the line of section till the offset, and use all this information uses all this information to create a raster image. So let's try to create one. So floor forward view, choose the resolution, defined area, and define. And there we go. And same as defined area, as we use screen area in floor plan view, it works the same here too. It uses the area of the view which is visible in our screen. And let's try to create one. So floor forward, your resolution, and then screen area. And there we go. So then we have a center view. It's same from the line of section. It creates offset on both sides of in total 70 millimeter, same as floor plan view. So ceiling view, then use resolution, defined area. Let's define. So if we turn off all other views, we can see it's just the same as we did in the floor plan view. It uses only thin part of that thin slice of the point cloud, use that information to create a raster image. And then we can also create a backward view. So backward view is from the line of section towards the back of it and the same length as the far offset. So let's try it. So floor forward, we can choose backward, defined area, and it'll define. There we go. So from this line, now we can see this furniture here, and in floor forward view we could see this part of the view, this furniture. So we can manually change this information also depending on the results we desire, and also change the offset. So offset is, again, it changes the line of section. If we put minus 500 millimeters, so it will go half a meter back, and vice versa. So this is how we use detail images in section. So far we have learned how to create detailed raster images using Undet for Revit in floor plan views and sections. Now we'll learn how to use the coloring part of the slice manager. So by default it uses plane as coloring method. So in plane coloring method, it changes the color at whatever interval size we define according to the elevation. So the elevation, the elements which are at lower elevation, their color will be bluish on the left side of the palette, and as it grows in elevation, it will move towards the right side of the palette and color it according to that. So let's try to use other coloring methods and see how they work. So we already have an example for plane. Let's try to make another floor forward view with intensity. So intensity works on the amount of point cloud we have for those locations, not according to the elevation. So this kind of image is useful when we have small different in planes of elements, but we still want to see that information. So this intensity coloring method comes in handy at that point, and we can always play around with them and to see which settings give us the best desired result. Then we have black and white as coloring method. So as it says, it just uses two colors to create the raster images, which is black and white. There we go. This coloring method is mostly useful for center view, and because it just gives us a boundary, and it's good to have that boundary in a monocolor, and which is always best. Then we have source. So for this point cloud file, we have images within the point cloud of all the external walls. So let's try to go to one of the external walls, and as we see, we have already created one by source. So let's try to create it again. So floor forward view 5 and coloring method is source, and defined area, define. So what it does is it uses the photos of the building and it creates raster images in them. So it's basically exact photos of those buildings. You can see the colors, you can see small details which you cannot see in other coloring methods. For example, the bricks and some smaller elements. There we go. So as we can see, all the bricks and all the smaller details. So right now it's kind of mixed up because there is another setting called calculate distance. So it's better to use source with calculate distance, and we'll talk about it what this does in last part of this video. So let's update. And now as we can see all the informations like brick structure, windows, their colors and everything else. See the small details on the doors which will be hard to see usually with plane, and pipes and everything else. So it's just a photo of that building and created into a raster image. Then we have interval size and palettes also. So when we create images, floor forward view, let's say plane, I would always prefer to use this palette because it has more distinguished colors at different elevations. So let's try. So I use this color palette most of the times. You see the difference between other images and this part of the image. This helps us to see different planes better and different objects because of the distinguished properties of the colors. And we have many other palettes also. You can always play around with them, see how they works, and if you like which one is your preferred one. Then we have interval size. So right now by default interval size is at 20 millimeters. So what it does is it changes color using palette at every 20 millimeters of difference. So if we change it, let's say to 5 millimeters of difference and update the image, it will change the color at every 5 millimeter whenever there is a change in elevation or a plane. So you see, best example is this. Before, if we go back, we had only 1, 2, 3 changes in color in this chair, and after we change the interval size to 5, it has multiple ones. So this is how we use interval size when we want to have more information about slopes or change in elevation, or two elements which are not at the same elevation but has a difference somewhere lower than 20 millimeters. So we can also change interval size at that point. Then as we talked about calculate distance just now, so let's see what calculate distance actually does. So right now we see we have many different colors clouding information in this part. So calculate distance, what it does is use only, it prioritizes the information which is above the other information. So let's try to create an image without. So let's find a table somewhere. Yep. So let's create a floor forward view without calculate distance. And now with calculated distance. So as we see the difference, the Undet for Revit will realize which points are above and have more priority than the others, and give us better image and better understanding of the elements. For example, now part of the table is mixed up with the floor, but if we use calculate distance, it uses those elements as it prioritizes the element which is above and create the image at a better understanding. Same goes for this element which is above the table. So we cannot see the proper dimension of this book, but if we use calculate we can have a proper image of that book also. So this is how we use calculate. So there are many other tools in Slice Manager also. For example, Raster Manager, Show All, and all these elements. So let's try and see what they actually does. So if we click on Raster Manager, what it does is it shows us all the images created in this view, in the selected view, and control its visibility like this, or we can also rename them if we need to. Let's say it was floor forward view, so we can rename them, or we can also delete them. For example, let's say I don't want this image, so I can just delete them. And this is how we use Raster Manager. The naming of default images are as we see, are based on the settings. So if top is for floor forward, bottom is for ceiling view, center is for center view, and then the three data, numerical data, which is elevation, thickness, and the offset. It's very helpful when we have a lot of images and we want to hide most of them and only want few of them visible, like this. So let's turn on all of them for now. Then we have Scan Position Manager. So what it does, it shows us all the groupings of this point cloud file. For example, for this project, we have point cloud file divided into three parts: external, ground floor, and first floor. So what it does is, let's try to make a small section. And if all of them are checked, and if we create an image now, it will use all the point cloud we have, all the points we have, so which is first floor, ground floor, and external. And with the same settings, if we uncheck, let's say, external and first floor and make an image again, it will only make the raster images using only the point cloud in the ground floor. And same goes if we check only first floor, it will only make image for the first floor, and external only for external. So it depends, sometimes when there is data overlapping and we want only specific part of the building, we can always uncheck and check the parts of the groups of this point cloud file. Then we have hide selected here. So whichever image we select, we can hide them just by click it. And we have another one which is show all images, which turns on the visibility for all the images. Then we have sort images. So sort images, what it does is bring smaller dimensions, images with smaller dimensions on the foreground and with bigger dimensions in the background. So let's try it. So when we click it, all the smaller images comes in the foreground and bigger ones goes to the background.